All right. Okay, so these videos are meant to be practice sessions to go along with lectures that will hopefully be coordinated by Mr. Flynn because he has the technological knowledge how to do it. And trying to create a library series here of different algorithms and skills associated with them. So I'm hoping to make 2 or 3 videos a day of we're gonna do 5 or 6 problems. And that way, we're gonna try to go from Algebra 1 all the way up to Calc AB. And it's gonna probably take 2 years. So we'll see how it goes. All right, so our goal in this video is to be able to write differences like pi minus e as products. All right, we'll start where the concept probably originated from. There was a couple of initial conditions, and here they are. Now notice, I really phrased this topic differently than an Algebra 1 textbook would. Because in the Algebra 1 textbook, we would call this the difference of 2 squares. Okay, but I'm here suggesting that difference of any numbers, provided the first number is positive, and the second number is as well, because if the second number was negative, a minus wouldn't be a difference anymore. Okay, so all we're doing is starting with a positive number. And why don't we do 49 minus 25? The difference of 2 squares. Many of you have probably already done Algebra 1 and moved on. Maybe you've already anticipated what I'm about to say. Square roots. Right? The length of a side of a square is technically a square root. And so what's the factored form for 49 minus 25? 7 plus 5. 7 minus 5. All right, 50 minus 25 is 25, so I think that's 24. Well, that's 12 times 2. I guess I can make that statement. So what we're going to do now is just do a bunch of problems so that that skill stays with you, and we'll write it differently from time to time. Okay, let's have at it. So let's try the famous one. A squared minus b squared. A squared minus b squared could have been written as working with a and b. A plus b, a minus b. Easy enough. Let's try a little harder one. Let's try, 9m squared minus 25y squared. I think we're looking at 3m, 5y. So I guess we have 3m plus 5y times 3m minus 5y. And if we let y equal a number and m equal a number, that minus that should be the same as plugging the numbers in here as well. Now we'll get a little more difficult. Climb the ladder a little bit. I don't know at what level I'm going to expect you to know this, but how about we add m to the 4th minus 25. M to the 4th is m squared. Let's change it to m to the 6th. Well, the square root of m to the 6th, m to the 3. Let's change it to m to the 10th. The square root of m to the 10th, m to the 5th. My God, I think there's a pattern here. Yes, because the square root of m to the 10th is m to the 5th. And I could have rewritten that as m to the 10th to the 1/2. And it's also m to the 5th. And we've been talking about that exponent. Yes, it means the square root of. We'll be playing with that in a little while too. All right, so let's stick with this one. So what is m to the 10th? What is m to the 10th minus 25? It actually is m to the 5th plus 5. Well, let's make this 12. Okay, and that makes that m to the 6th plus 5 times m to the 6th minus 5. And we actually call this the conjugate. That's the conjugate of this. When we multiply it, we won't get any middle terms. Right? Because you got a plus 5 and a minus 5. We're going to be using conjugates in a little while. in another context. All right, let's keep having some fun here. Let's do 7 minus 5. Nah, that one is too close to pi minus e. No, we said it, we're gonna do it. So, well, I guess that's the square root of 7, and I guess that's the square root of 5. Seems to me I should be able to say the square root of 7 plus the square root of 5 times the square root of 7 minus the square root of 5. Sum of the square roots times the difference of the square roots. So does it really matter what I put in here? No. Is there another way to write that? Yes. 7 to the 1/2 plus 5 to the 1/2 times 7 to the 1/2 minus 5 to the 1/2. What happens to the middle terms? 35 minus 35, gone. And what is the square root of 7 times the square root of 7? Some of you may not quite know yet, so let's do an easier one. Let's do 9. What's the square root of 9? Times the square root of 9. By golly, I think it's 9. Let's make 19 now. What's the square root of 19 times the square root of 19? Put it in a calculator. You're going to get 19. What's the square root of any number? Times itself. Square root of n times the square root of n. Let's put it over here and write it this way. Those are inverse operations. You get the number that's inside. So does it matter what we write here? No. So let's have some fun with one. Let's put something funky in there. Let's put 83, m to the 7th, y to the 4th, minus 91, ZB. ZB. So what is your answer? Square root of 83 m to the 7th y to the 4th plus the square root of 91 ZB times the square root of 83. You can see why nobody does this. M to the 7th y to the 4th plus, I already did the plus, minus square root of 91. So last one I'm doing, ZB. You multiply that out, you get a square root times a square root, which we were practicing just a second ago, and a square root times the square root of itself. You get what's inside, and the middle terms cancel. So is it really the difference of two squares? I guess you could still call it that because I am putting those numbers in the square. So I guess I got to retract what I said at the beginning, but you don't have to have perfect squares. Well, these are perfect squares. Like this is, so I don't know what language to use here, but I wanted you to see this. So therefore I wanted you to think about it because I wanted you to see it. And, I hope you give it, a little bit of attention. As there are problems that you can do. I just saw one the other day. I'll put it on the test as a challenge question. Nice little problem that has something to do with this. So keep your eyes open for it. All right, there's another one. That's 3 down today. 3 rapid fire videos. All right, see you tomorrow.